Hello, everybody. Welcome to another video about quantitative measurements and research tools, trying to help make the scariness of statistics a little bit more user-friendly. And so jumping into today's video just right away, the goal of this video is to focus on how to actually analyze your data once you've collected it. Okay, because at this point, assuming for the video, we have gone out, we've collected our data, and now we need to know what to do with it. And so the approach for this video is that I want to quickly just review Noir, just because it just gets us back in the mindset of, that's what that was for again. And then the main focus of this video is going to be, okay, now that I remember Noir and I have this data, what tests should I actually run? And what do the tests help me understand about the data, the results that I see? Okay, and then I'll just have a brief little reminder there about making sure, again, now that we've seen this data analysis at work, why we should be so careful to make sure we proactively, purposefully collect data. And so jumping right in, um, Noir, if you remember, we had this discussion in a prior video about the types of questions you ask, the types of data you collect are not treated equally. So nominal data being that you can only really judge the variable by name and name only. That you can say these are male, these are female. You can't say anything about better or worse, higher, lower, greater, less than. You can just say they are different. Compared to ordinal, that they are different by name and also that there's an order. Freshmen, sophomores, juniors, seniors, it does indicate something by the order that you're talking about. Interval data that basically we have the name difference, we have the order difference, but also each of the orders are proportionally different. A reminder being that it might take a year to go from private to private first class. It might take 20 years to go from command sergeant to sergeant major. Don't quote me on that, just as an example. But in an interval, a 1 to a 2 difference should be equivalent to a 4 to a 5 difference or a 6 to a 7 difference. That each of the proportions of intervals are equal to one another. And lastly, that ratio data, everything's equal. We have name, order, proportion, intervals, but also that we have a 0 point. We have an equivalent starting place to base all of our calculations off of. Day somebody was born, how long something took, how old someone is, their height, their weight. And ultimately, with these 4 levels of measurement, the more you go into Noir, the more meaningful the data is. And that also, the lower you go into Noir, the more you can still do the other things too, because you have better data and can then visually bin it to your own heart's desire. Okay, so that's a quick review of Noir because it'll help us with analyzing our data. At the end of the day, you've got to decide most of the things that you'll do based off a couple different test types. Okay, and I should have regression here, and I will talk about it in a moment. But for the sake of this class, this beginning class, regression isn't going to quite be the one we're going to be using for the most part. So I'm going to focus on the ones that you probably will have to choose from. The first one being chi-square. Now, chi-square is when you're comparing frequencies of data, or said a different way, you're just basically looking at how many times something happens. And the question is, did this thing happen more than this thing at a significant level? In other words, when 10 people said yes, but 7 people said no, is the difference of frequency between those two values enough that it warrants studying a little bit farther? Okay, and from class, we know that there's 2 different types of chi-squares that you might run when you're either looking at single or multiple categories. But the end all of why we would conduct a chi-square study is largely seeing whether things happen more or less from one another. Okay, so just as one example, you want to look at vote by gender, and I just 2012 to try to get away from maybe some of the more recent political stuff. You want to look at how much women voted for one candidate versus how much men voted for one candidate. That is a quick chi-square test, and we can see whether it was statistically more likely that a man would vote for Romney or that a woman would vote for Obama than the numbers show. And the statistical likelihood for interpretation's sake here is, does this number, this difference between these 2 columns, matter beyond just pure chance? if we did this study again, the same categories, the same topic, would we be likely to find this again? And it wouldn't just be the opposite next time because numbers can be random, right? Did this difference here happen because of something important? That's what a chi-square test ultimately tells you. Now compare that to a t-test. Whereas chi-square is about counting frequencies, t-tests are about comparing, and important here, mean differences between two groups. And mean, we're talking, right, the average difference. So we're putting all the people in two groups. So again, you could do males and females. You could do things like when students took this class or when they took a test before the lecture and after the lecture, that'd be them grouped two different ways. We're looking at whether group one and group two significantly differ on ultimately what happened to them on a Y category, right? A dependent variable. So when males and females, do they actually significantly differ in height, for instance? Or did they differ on how well they did on a COM 630 statistical test? Okay, so that's a t-test, comparing two groups on a continuous Y variable. ANOVAs are basically t-tests, except sometimes you have more than two groups, don't you? Sometimes you don't want to just know males and females. Sometimes you want to know freshmen, junior, senior, and sophomores. Well, that's more than two categories. In t-tests, you can't do more than two categories. The way the math works, you need to compare A group to B group. On the flip side, ANOVA gets around this. It does math just a little bit different to allow us to see the difference between multiple levels of groups. And the important thing here with an ANOVA, and these are a little tricky, so my note here, using one-way ANOVA for this class, what I'm saying is beyond one-way ANOVA, we're not going to do that in this video and in this semester because ANOVAs are great for a lot of reasons. They also can become very scary and tricky quickly. As you can see down here, you got ANOVAs, MANOVAs, ANCOVAs, MANCOVAs. Oh man, things heat up pretty quickly with ANOVA testing. And importantly with ANOVA testing, there's two different things that it does test. Number one, so you have a test to see whether there's actually a significant difference between the categories. So maybe you want to spend time looking at whether how much a student reads the textbook, low, average, high amounts, and what grade they get in the class. The first test for an ANOVA tells you, was there a difference between these categories at all? And that's all that first test gives you. And that is where you get this F statistic here. The F tells you whether there's enough of a difference that something here is happening beyond mere chance. But then you have to actually do what are called post hoc tests, and I'll give it a different video. But the post hoc tests are where you go back then and say, all right, if there is a difference, now tell me how there actually is a difference. And basically, at that point, the post hoc tests, though, don't quote me on this, just as an example, are basically conducting a bunch of miniature t-tests between the groups once you know that there is a difference in the overall ANOVA test. Okay, so those are ANOVAs. They're just a little bit bigger t-tests at the end of the day. When you have multiple categories, you got to look for differences between. Okay, our next type of test, correlations. Correlations are when you want to know whether two variables are related to one another. And importantly here, they have to be continuous. They have to be at least interval or ratio level data, which I'll come back to in a moment. But maybe you want to know if how old a person is relates to how fast they can run. How much ounces of soft drink a person drinks versus how much weight they actually weigh. Okay, video game hours played versus the intelligence of a person. With correlations, we're just largely looking at, okay, of X and Y, weight and soft ounce or ounces drunk of soft drink, of video game time and of intelligence level, how do the dots happen in relation to each other? And I've got a different video for correlations if you want a deeper look into this. But the ultimate interpretation we're looking at is, do the dots move in a similar pattern where when one goes up, the other goes up, or when one goes up, the other goes down? We want to know how those variables are related to each other. Now, finally, regression tests. And this is the one I said is a little bit above, but I just want to give you some familiarity moving forward. Regressions are kind of like fancy correlations in that, much like ANOVAs, t-tests, they were like allowed you to do more than two for a t-test. Regressions allow you to do more correlations than just a basic correlation test, kind of. But the very important thing with regression is they're more about prediction than they are relationships. We can have a whole bunch of variables in a regression test. And again, more on that in a regression video later. But the big question then ends up being, if we do X, will Y change? And if it does, how much will it change? Right? So again, you'll notice a lot of these variables are similar here, age, weight, height. But if a person's blank weight and blank age and blank height, how long are they likely to live based off these other variables? Okay, that is ultimately what a regression looks like. And to me, regression is some of the coolest testing you can do. It ends up providing a lot of the questions people actually want to know answers to. It is a little bit more demanding than some of these other tests. And so I just want to provide that there, for basic comprehension for now. But ultimately, now you have these different test types. I just want to remind us that, again, why we've covered nominal, ordinal, interval, and ratio noir at the beginning of this video. Remember that you can't actually, the way the math works, you cannot run some of these tests if you don't have the appropriate data levels to run them. Chi-square frequencies only work for nominal and ordinal data. If you try to run a chi-square for interval ratio, even though the SPSS will give you numbers, they don't mean anything. They're problematic. If you only have red and blue as your category system, you cannot predict red versus blue versus green versus yellow on the likelihood of someone weighing a certain amount of weight. The math just does not work. And so ultimately, an important reminder here, depending on the types of hypotheses and research questions you have, those dictate which kinds of tests you need to run. And you can only run those tests if you have the appropriate levels of data to begin with. And so I can't stress that enough. When you're collecting your data, really do your best to proactively collect it to make sure that you have the ability to be flexible with whatever tests you want to run. Now, one final thing, and again, this is in my other video, but just as a reminder, there is a weird little thing that happens with nominal data, male versus female. If you put them in a 0-1 scoring system as opposed to a 1-2, you can actually treat them like a continuous variable, like ratio level data. The male is the 0 true point, and the female is the 100%, a 0 to 100% scale. The interpretation is just a little goofy in that you'll only ever get a 0 or a 0.5 here or a 1. Basically, either from 0 to 1, the number goes up or it goes down. And so what that tells you is if it goes up and we scored at 0 to 1 here, that means females, as we look at females versus males, these other numbers that are going up or down then. So notice this one, female 1, and a negative correlation here. How funny are you? People found females to be less funny, would be how you would interpret that with this 0 to 1 coding. So they call this dummy coding, just fun trivia for you. But ultimately, that is a quick overview of how to actually choose what tests you need to use to analyze your data. A reminder that the data you have dictates the tests you can use, and the tests you use should be driven by the research questions and hypotheses that you would need to answer. If you can remember this and how all these things relate in terms of deciding which tests you need to run at the end of the day, you'll be able to answer almost any question that you want to in your lives, statistically anyway. And with that, I hope this video has offered you something new to consider with quantitative statistical analyses, and I wish you all the best today in applying this all now.